Here is our video over chemical reactions, and the big question is, how do we know that a chemical reaction has occurred? When a substance changes physically, it is still the same substance. For example, ice is frozen water. If it melts, it becomes water in a liquid state. Regardless of being a solid or a liquid, it is still water, and this is a physical change. Okay, so before we get started, we need to talk about what a chemical reaction is. We use equations to represent chemical reactions with chemical formulas. So think about a chemical reaction like a math equation. You have two sides to every equation. So for example, y equals mx plus b has y on one side of the equation and mx plus b on the other. In chemical reactions, there's two sides to the equation as well, your reactants and products. Reactants are the substances that you start with. In this example, ammonia and hydrochloric acid are the reactants. Products are the substances that you end with. If the products are different substances than the reactants, then a chemical reaction has occurred. So if you look at our example again, we end with ammonium chloride. Ammonium chloride is a new substance with new properties different from the reactants, so a chemical reaction has occurred. A good strategy to add to your periodic table is the wrap strategy. So find some blank space on your periodic table, write a capital R, a lowercase a, and then an uppercase P, draw an equal sign, and then write reactants, draw an arrow, and write products. Flashback time. Remember valence electrons? These little guys are the electrons on the outermost orbital of an atom. They're responsible for reactivity because as atoms approach each other, these little dudes will come into contact first. Remember that electrons must follow the 2-8-8 rule, where 2 electrons go on the first shell, 8 on the second, and up to 8 on the third. Atoms that do not have 8 electrons on the outside shell are not full and are therefore reactive. Atoms which do not have a full outer shell are reactive because they will want to gain, lose, or share electrons in order to have a full shell. This is why chemical changes occur. When atoms gain, lose, or share electrons with other elements, new substances are formed and properties change. A chemical reaction is a process where one or more atoms of a substance or substances are rearranged to form a new substance with new properties. Since we cannot physically see atoms breaking and hooking up with each other, we need to look for evidence of a chemical reaction. Some common evidences are temperature change. This can be exothermic or endothermic. Exothermic means heat is released, so the temperature goes up. Endothermic means heat is absorbed, so the temperature goes down. A color change is also evidence, but we have to be careful here, which I will explain more later. Gas production is evidence, which is seen when bubbles are released. Again, you have to think about this one for a bit. It's not always evidence. When a solid forms out of a solution or from liquids, then we call that a precipitate. And then the last evidence is an unexpected odor change. Two liquids together and a solid begins to form. This is called a precipitate, which is evidence of a chemical reaction. However, just because a liquid freezes does not mean a precipitate has formed. This is just a physical change. Precipitates must form out of solution. In order for a temperature change to be considered evidence of a chemical change, the change in temperature must occur because of their reaction, not because you physically added or took away heat. Think about our demonstration with poly A and poly B. When we mixed the two liquids together, the cup began to warm. This is evidence of an exothermic reaction and counts as evidence that a chemical change has occurred. However, if you are boiling water, you're adding heat to that boiling water, that is not evidence of a chemical change. Color change as evidence of a chemical reaction, you have to really think critically. For this to be true, the color change must be unexpected. So consider this. If you add green food coloring to cake mix, the cake turns green, right? This is not a chemical change because it is not unexpected and the green can be taken out. However, let's say we combine two clear liquids and a yellow solid appears. You wouldn't expect two clear liquids to turn yellow, so this would be evidence that a chemical change has occurred. Let's talk about poly A and poly B again. We started with two different transparent brown liquids. After mixing, they turned a cloudy, creamy white. Boom, color change, chemical reaction. Take a look at the video with clock reactions on Canvas that shows lots of other evidences of a chemical reaction. If the odor of the product is different than the reactants, then this indicates that a new substance with new properties has been formed, i.e. a chemical change has occurred. If you think about our poly AB demonstration, the smell did change from beginning to end. Gas production can also be evidence of a chemical change when it is produced during the reaction. We know a gas is produced if we see bubbles. However, you must use caution here too. So think about this. If you boil water, do you see bubbles? And the answer is yes, but these bubbles are not from a chemical reaction. It is just liquid water evaporating into gas water or water vapor. But if you combine a liquid and a solid and the solid begins to effervesce or dissolve and form bubbles without any outside help, then this is evidence of a chemical reaction. Remember poly A and B again? The substance was expanding because a gas was being produced during the reaction. All right, during the video, what evidence of a chemical reaction do you see?
It's been a whole week since I've been on fire, but today is a new day.
You've been fine. Hey, I was talking to the kids about energy, and it's hard to teach kids about food having energy sometimes. And so I wanted a demonstration to be able to show this, and this is a classic. It's the gummy bear demonstration. And what we have here is we have a powder that's been turned into a liquid. You'll see I'm using the blowtorch. We have to tell our viewers you don't do this at home. Hold this up and show them if you don't mind. This is a powder. Stay away from here. This is a powder called potassium chlorate. All right?
Powder close to the flame.
Yes.
It's
this,
what?
Called potassium chlorate. Similar to that white stuff that's on the end of a match. There's a red and a white stuff that's on the match.
Oh, wow.
Yeah. So this is a strong oxidizer, meaning that when we liquefy it like this, it's ready for any organic to go inside, and we're going to call the gummy bear an organic. So you're a big runner. You know that you carb up before you run.
Right.
So gummy bears over here, and you can take a look at the gummy bears, make sure they're okay. So the gummy bears there are just regular old gummy bears that are full of a lot of energy. All right. So here's what we're going to do: is I'm going to put the gummy bears down inside here, and I want you to watch what happens. Ready? So
Should I stand back?
If I were you, I would. Ready? So gummy bears go down inside like this.
Oh, gee.
Take a look at the tremendous amount of energy that's given off.
People
This
eat
fire.
these things.
Isn't that amazing? Now look, the fire is shooting out here.
Oh
Look at
my
all of this
gosh.
energy being released by the gummy bears.
It's almost like jet propulsion.
Isn't that amazing? So when you're teaching kids that carbohydrates have a lot of energy, it's just the perfect fuel for this oxidizer.
Is that
that's
what
here.
they look like when I eat them?
But now you can run a little bit.
Oh my
The small
gosh.
amount of smoke that's going through the trees, not a big deal at all. Look at this one. This is one that we practiced with you. This one's a cool one, so you can touch this one. Look at the flask, and you can really see the reaction that happens inside. So there's the chemical reaction that takes place inside. So literally we release that. It serves as a fuel, a strong oxidizer like that, and you have experienced the famous screaming gummy bear laugh.
I had no
Amazing.
idea. Can you
Absolutely amazing.
this powder with the what is potassium? What
What's called
was the
potassium chlorate.
Is
That's
that
just a strong oxidizer.
That's something that
Yeah.
chemistry teachers would
It's
use
a-
in the classroom.
This is a classic in the chemistry classroom. See, I get to bring these to you because there's a lot of people.
So let's review these examples. Ice cream melting is a physical change. You are going from solid ice cream to liquid ice cream. It may not be as appetizing, but it's still ice cream. The same thing goes for dissolving sugar in water. The sugar goes from a solid to a liquid and forms a solution with water. The water does not change chemically though, and neither does the sugar. They are mixed together but still retain their properties, so this is a physical change. You can actually boil the water until it evaporates off and you will be left with sugar. Anytime something burns, it is changing chemically. So gasoline burning forms a new substance with new properties. This is evidence of a chemical change. Milk souring is also evidence of a chemical change. If you've ever drank fresh milk, it is a liquid and it's refreshing and creamy. But if you've ever drank sour milk by accident, the taste is sour or vinegary. It has a strong acrid smell and can be chunky, which is really gross and evidence of a chemical change.